6. Okay, who'd like this one? Alright, Saul.
Well, since combustion, we need to, add oxygen. So we add O2.
So always you have the thing you're combusting and the other reactant is oxygen. And what do you always make if it's complete combustion?
Carbon dioxide and, water.
Always make carbon dioxide, always make water. Now we haven't been putting our phases in here at all. PBI2 would generally be a solid. Usually I2 is a gas in its elemental form. For these, I think this would be a liquid, that would be a gas. I would give you this, but you guys always know that the O2 in the air is a gas, and that's what you use for combustion for that other reactant. Combustion's always hot, so your other two products will be gases. Now, is it balanced?
No.
So what do I do?
We need to multiply the carbon and hydrogen by 2, because when you have complete combustion, both hydrogen and oxygen are homonuclear diatomics, so you can't have a 6:3 ratio. Oh no, you have carbon and hydrogen on the left side.
Carbon on the left side, this side?
Yeah.
Okay. Try again. I will try that again. Carbon here. Oh, the hexane. Okay.
Yeah, because you can't have a 6:3 ratio of hydrogen and oxygen.
Okay, now is it balanced?
No, then we need 15 oxygen
15
to
here.
there, and that'll make 12 carbon dioxide and 6 H2O.
Okay, so now we add up. We've got 12 carbon, 12 carbon, 12 hydrogen, 12 hydrogen, and then the oxygen is the tricky part because there's oxygen in both. So 12 times 2 is 24 here, plus 6 is 30 oxygen. And then here, 15 times 2 is 30, so that's good. So kind of key point is this odd oxygen here is causing trouble because you know this is always going to be an even number. So you've got to get this to be an even number. Then when you have these that have a coefficient everywhere, it's really important to check because sometimes you end up kind of trying and trying until you kind of double everything. Like a common mistake with this would be you would end up trying and trying until you got this. Right, and you just end up with double. If you can divide every coefficient, all of them, through by 2 or 3 or something, then you need to reduce it down to its simplest form. But you didn't do that this time. Some people did do that on last test. So something to be cautious about because that's really easy to do. I end up with that sometimes, so you just have to check that as kind of a last step. All right, so the mass of H2SO4 molecule in kilograms. And you get the conversion factor, 1.66 times 10 to the negative 24. What grams is 1.00 AMU. So 3 significant figures in each of those, which you have to consider. Who'd like to try this one? Okay, Lily.
Okay, so first we have to find the molecular mass of the molecule.
So this is H2SO4. You could call it hydrogen sulfate, but nobody does. It's sulfuric acid. This stuff I decomposed the sugar with last week.
So we know that there's 2 hydrogen atoms, and each of their mass will be 1.01, and then there's 1 sulfur atom, 32.1, and 4 oxygen atoms.
So that's 16 times 4. So if you cut one in half and double the other, that's 8 times 8, which is 64. Everyone knows that trick? If I'm doing that, so oxygen's mass is 16, and there are 4 of them. Maybe some people can do that in their head, but I'm not one of those people. But if you cut 16 in half, you get 8, then you double 4, you get 8. And they'll have the same answer. It's just like prime factoring and then multiplying. Always cut one in half, double the other, or divide one by 3 and multiply the other by 3, or something like that, and you can do bigger numbers in your head. But anyway, SAT math.
So the total mass is 98.1.
Okay, 98.1, and notice that Lily rounded, because the only one that has significance in the hundredths place is the hydrogen, so we have to round to the 10th place. That 2 doesn't make the 1 go up. So it's just gonna be 98.1, and what is the unit on that? So 98.1 AMU is the molecular mass of sulfuric acid.
And then we'll convert that to grams by
Maybe I'll move down here.
putting the AMU over 1 and multiplying it by 1.66 times 10 to the negative 24 grams over 1.00 AMU.
So notice that she's keeping her units in the math, which is important, showing her work, and using units to cancel units. So if we were going to convert straight to kilograms, I know a lot of people like to kind of stop and do each step at a time. I just kind of go right through until I get the units I want. So how would I change grams to kilograms in the next step?
I did 1 kilogram over 1,000 grams.
And that 1 is perfect. This 1,000 is perfect, so you don't have to worry about them significant figure-wise. So that cancels my grams and gives me kilograms. So then I just take my calculator and do 98.1 times the conversion factor divided by 1, which is nothing, times 1 divided by 1,000, and I get that answer. I know there are lots of other ways you can convert to kilograms, but that's one of them. So what do you get?
I got 1.62 times 10 to the negative 25.
Okay, so anyone have a different answer for that than I have?
I got 1.63.
That's what I got.
1.632.
Because I rounded to 3 significant figures after multiplying.
Okay, let's see, 98.1 times 1.66, 4 divided by 1,000. Yeah, that I get 1.628, and the 8 will make the 2 go up. But you're correct to, and that wouldn't be such a terrible big deal, although it should be 1.63. But you're correct to have 3 significant figures there, because this has 3, that has 3, that has 3, and those guys are perfect. So you've got around to 3. Super job. Okay, so now we've got to discuss that number 5. Why is it dangerous to use propane torch in here? Why does Mike turn on the fan? Why do we open the window? Sorry.
This is there's a limited supply of oxygen that could start forming carbon monoxide.
Carbon monoxide. Okay, so key points for the test. When you answer a question about why is it dangerous to do this with your fireplace or that with your furnace or run your car inside the garage or what have you on the test, the key point to that answer is you've got to have 2 parts. You have to tell me what you're forming. So what's the compound we're forming that's bad? CO, carbon monoxide. And you have to tell me why that is forming.
Lack of oxygen, incomplete combustion.
Incomplete combustion, lack of oxygen. So you want to say carbon monoxide, you want to say incomplete combustion.
So those are
the 2 key points on the test. Because, I mean, I get kind of very short, nondescript answers. And the question really doesn't specify on the test, but I'm telling you now, when you tell me about why something is dangerous, it needs to be because, this is not working. Okay, maybe that'll work. Because carbon monoxide is formed for incomplete combustion. So, now we get to, all right, so is everyone good? Formation is going to have elements forming the compound I give you. Decomposition is going to have a compound broken down to its elements. Careful if there's a homonuclear diatomic in the group. You may have your periodic tables out. No, you can't have your periodic tables out during the quiz. Everyone had memorized those homonuclear diatomics, right? You were supposed to. combustion is gonna have the thing you're blowing up plus oxygen, makes these two products every time, carbon dioxide and water. And there's not one of these on the quiz, so you're good. So, I'm gonna give out the quiz, you can put everything away but your pencil. And, I never got that for quiz before. I'll write the extra quiz questions on the board. So while you're doing this, I'll write them up there, and then you can start on them as soon as you finish the first part of your quiz.
You do it on the piece of paper.
Yes, just do it over here in the extra white space. All right, turn them over and start. Did I give you one, Jenny? You don't have a periodic table on the front of that. No, but okay. Did you turn the camera off? Boring.